Residual chlorine in drinking water. The presence of residual chlorine in drinking water is important because it provides ongoing protection against the growth of harmful microorganisms in the water supply. The level of residual chlorine in drinking water is carefully regulated and monitored to ensure that it remains within safe levels. The amount of residual chlorine required in drinking water will depend on a variety of factors, including the quality of the water source, the level of contamination, and the specific requirements of the treatment process. In the United States, the Environmental Protection Agency, EPA, sets standards for the maximum allowable levels of residual chlorine in drinking water. The EPA recommends a minimum residual chlorine level of 0.2 parts per million, ppm, to ensure that the water supply remains free from harmful microorganisms. While residual chlorine is an important component of the disinfection process, it can also have some negative effects on the taste and odor of drinking water. Some people may be sensitive to the taste and smell of residual chlorine in their drinking water, which can make it less appealing to drink. To address these concerns, many water treatment plants use alternative disinfection methods such as chloramine, which is less likely to affect the taste and odor of drinking water. It is important to note that chloramine can also have some negative health effects if not properly managed. So careful monitoring and management of the water treatment process is essential to ensure that the water supply is safe and free from harmful contaminants. Health effects of residual chlorine. While residual chlorine in drinking water is an important component of the disinfection process and helps to protect against harmful microorganisms, it can also have some potential health effects if present in high concentrations. Exposure to high levels of residual chlorine in drinking water can cause irritation of the skin, eyes, and respiratory system. This can manifest as symptoms such as redness, itching, and burning sensations. Some people may also experience gastrointestinal symptoms such as nausea and vomiting if they consume high levels of residual chlorine in their drinking water. In addition to these acute health effects, exposure to high levels of residual chlorine over the long term can also have some potential health risks. Some studies have suggested a possible link between exposure to high levels of residual chlorine and an increased risk of certain types of cancer, such as bladder and rectal cancer. However, more research is needed to fully understand the long-term health effects of exposure to residual chlorine in drinking water. To minimize the potential health effects of residual chlorine in drinking water, it is important to carefully monitor and manage the disinfection process to ensure that residual chlorine levels remain within safe levels. Water treatment plants may also use alternative disinfection methods, such as chloramine, which can be less irritating and have fewer potential health risks than residual chlorine. Measuring residual chlorine. Measuring residual chlorine in water is an important aspect of ensuring that the water supply remains safe and free from harmful microorganisms. There are several methods that can be used to measure residual chlorine levels in the water, including test strips. Test strips are a simple and inexpensive method of measuring residual chlorine levels in the water. These strips contain a chemical reagent that reacts with residual chlorine to produce a color change that can be compared to a color chart to determine the residual chlorine concentration. DPD method. The DPD, N-diethyl p-phenylenediamine, method is a more precise method of measuring residual chlorine levels in water. This method uses a reagent that reacts with residual chlorine to produce a colored compound that can be measured using a colorimeter or spectrophotometer. Titration method. The titration method is another precise method of measuring residual chlorine levels in the water. This method involves adding a reagent to the water sample that reacts with residual chlorine to produce a color change. The concentration of residual chlorine is then determined by titrating the sample with a solution of known concentration. The method used to measure residual chlorine levels will depend on the specific needs and requirements of the water treatment plant. Regardless of the method used, it is important to carefully calibrate and maintain the equipment used to ensure accurate and reliable measurements.